I'm Patrice Geoffron. I'm professor in Paris-Dauphine University and member of the organizing committee of that conference. And we are particularly happy to welcome you. Initially, the project was to welcome you physically in Paris last year, but for a reason that all of us know, we have been obliged to modify the organization. But despite that, I'm happy to open that session, which will be dedicated to consumer preference regarding the new mobility modes. As we know, there is a dense portfolio of innovation and new mobility modes, technologies, and we need to understand in the middle of that the evolution of the consumer preference, because that portfolio is particularly dense, and because the answer of the consumer will not be homogeneous in any country, any city, and this is why we have selected the panel of this morning, and I will present each of the panelists. And the first one is Kentaro Yoshida from Kyushu University, assessing consumer preferences for alternative fuel vehicle and autonomous driving technologies. Kentaro, you will be the first to speak, and I will present after that each speaker when his time will come. Okay, so if you're okay, Kentaro, you've got the floor for 20 minutes.
Okay.
Thank you.
I will share my slides. Okay.
Yeah.
Can you see this?
Perfect.
Okay, so good morning or good afternoon. Anyway, so it is 2 p.m. in Japan. So maybe in Europe it's early morning. So good morning. I'm Kentaro Yoshida from Kyushu University, and the title of my presentation is Assessing Consumer Preferences for Alternative Fuel Vehicles and Autonomous Driving Technology. Outline of my presentation. It is assessment of consumer preferences for alternative fuel vehicles and the autonomous driving technology in Japan. Now, alternative fuel vehicles includes plug-in hybrid and electric vehicle and the fuel cell vehicle and the hybrid and the green diesel. So, and autonomous driving and the driving assistance is classified into level 0 to 6, but I will use levels 0 to 3. And I will review factors affecting consumers' purchase decision. And I will use the best worst scaling, BWS. This is an extension of choice modeling with best and worst choices. I will use case 3, multi-profile case BWS. Let me explain a little bit about alternative fuel vehicle policies in Japan. So, major alternative fuel vehicle policies is pricing policies. It is classified into one-time deduction. A clean energy vehicle subsidy for fuel cell vehicle, it is about 2 million yen, and the electric vehicle 0.4, and the plug-in hybrid 0.2 million yen or so. And in addition to national government clean energy vehicle subsidy, there are many kind of local government subsidy for clean energy vehicle. For example, 0.05 million yen by the city of Yokosuka. And we have eco-car tax exemption. And in addition to pricing policies, there is many infrastructure subsidies about charging facilities and station electricity and hydrogen. Let me a little bit explain about deployment of hydrogen stations. There are 134 stations operating in Japan as of January 1st, 2021. It's covering all over Japan from Hokkaido to Kyushu. And but the government goal is by 2025, it's about 320 stations. And our optimum deployment of hydrogen station research, another research revealed that 400 to 2500 will be the optimum for deployment of hydrogen station. Anyway, so current status and the issues of fuel cell vehicles in Japan. So let me explain a little bit about current status and issues of fuel cell vehicles. As for passenger vehicle, Toyota Mirai is the most famous one. So in 2014, launch of Mirai and the total sales about 10,000. And Toyota released a new model in December 2020, last year. So, and the Honda in 2016, and the Hyundai is a South Korean company. So by it's getting very popular and popular in South Korea and other countries. So, and anyway, so the next slide shows a choice modeling and variation. This is the best worst scaling study of AFV. It is a new modeling approach to assess consumer preferences because classical or traditional discrete choice experiment, there are many kind of example and case studies. Classical and the traditional discrete choice experiment choose the most important profile, only the most important profile goods or with several attributes and levels. And most of the AFV variation studies apply to these discrete choice experiments. Like it is review articles by Liao, review 26. And the best worst scaling is a new modeling approach. It picked the best and worst options. There are advantages when facing a usual and unusual choice scenario, like gasoline or a hybrid is a usual option for Japanese people, and unusual is electric vehicle or fuel cell vehicle. So there are advantages to use best worst scaling for alternative fuel vehicles. But analyzing the data from best worst exercise for analysis is less straightforward than that in traditional discrete choice experiment. So that's why there are a few case studies of using best worst scaling. So the term minus xi will be added to the traditional experimental choice experiments. I will explain about data collection at the next slide. So online questionnaire survey in Japan, the samples were more than 2,000 monitors with a valid driver's license. And the survey was conducted in March 2019, and male and female 50%, and the age group is almost the same. So teens at 60%, and 20s, 30s, 40s, 50s, and 60s and older. And the car owner is included 80%, and non-user 18%, and the car sharing is 1.3%. Region is all over Japan, from all over Japan. Right, so when using discrete choice experiments and the best worst scaling, so survey design is very important for attributes. What attributes should we select? According to Liao, so there are so many kinds of attributes, but I selected the purchase price and operation cost and the driving range, reduction of carbon dioxide and pollutants emission, and blend diversity. Survey design, this is the orthogonal fractional factorial design was used, and 16 choice sets, each comprising 4 profile types with 5 attributes and 4 levels. And each respondent was given 8 different choice sets and 1 common profile that had the same price level for each profile. And the attributes of the profile are engine and or motor type, reduction of the cost, carbon dioxide emission, and a purchase price, operation cost, and the fuel electricity per 100 kilometer drive, and the maximum driving distance after filling up or at full charge. And the engine types used here were gasoline, hybrid, clean diesel, and the plug-in hybrid electric vehicle, and the fuel cell. And In addition to it, so respondents to bear an additional financial burden to purchase alternative fuel vehicles compared with purchasing a conventional gasoline car, which had the lowest purchase price. The purchase price of alternative fuel vehicles was established at up to 1.1 million yen. And the survey, survey design is like that. So when a respondent buy a passenger car, this is a hypothetical scenario. There are 4 types of cars that have 6 different engine models. The respondent chooses the best and worst car among 4 alternatives of profiles. The first one is the engine model. And the second one is the purchase price. It's gasoline plus how much yen higher. So based on gasoline cars, let respondents assume the desired price and set other models to be more expensive than the gasoline cars. And I used the autonomous driving level from 0 to 3 and plus additional cost. Level 1 plus 80,000 yen and level 2, 200,000 yen and level 3 plus 800,000 yen is fixed. And the fuel electricity cost and the maximum driving range and the carbon dioxide emission. Yes, and this is a summary of attributes and levels. Okay, let me skip this slides. For example, so for your information, this is SA automation level. Level 0 is no automation, and level 1 is driver assistance hands-on, and level 2 is partial automation hands-off, and level 3 conditional automation eyes-off. Now in Japan, level 3 is sold in the market, so but high. Okay, this is levels of driving automation in more in detail, level 0 to level 5. And this is an explanation about benefits of driving automation for drivers. So I used in the questionnaire survey. Okay. The respondent awareness of autonomous driving technology. Interest in autonomous driving technology by respondents is more than 50% is somewhat interested or very interested, but neutral is 16% and not so interested in the is like about 30% or so. And I asked the question about awareness of autonomous driving from level 0 to 5. If you use a self-driving car, answer the level you want at the present time, without considering the cost, the purchase price, etc. And level 1 and level 2 is about 20%, and level 3, more than level 3 is about 50%. Okay. Summary of cross-sub results of autonomous driving. Gender, male respondents are likely to be significantly higher than female respondents, and regarding reliability and the interest of autonomous driving. And the age group, different preferences for different age groups. Response rate for level 2 and level 3 was higher than those of other generation in their 60s or older. For teens, level 0 to 2 tend to be higher and level 5 lower. The proportion of respondents at all levels in their studies were nearly uniform compared to other generation. Households that do not own a car tend to be more interested in autonomous driving. And this is a best worst scaling multi-profile case example. So there are 4 types of engine or models as well as the conventional gasoline cars. It is fixed to car A and sold by a certain automobile manufacturer, which are the most attractive and the most attractive vehicles when you consider buying. Please select one by one. There are 8 different questions. I repeat 8 different questions with a different level for each attribute, engine, motor, and there are 2 experiments. One is with autonomous level experiment, and another one is without autonomous level. So, question. And the answer is I'm most likely to choose and check, and I'm least likely to choose check this one. So I can calculate. This is the best worst scaling multi-profile case with random parameters logic estimation results. And okay. Important thing is dummy for fuel cell vehicles was not significant. And green diesel for dummy for green diesel vehicle was negative. And autonomous level 1, 2, 3 has a positive sign and with significant results, but this is a marginal willingness to pay for autonomous level 1, 2, 3. Autonomous level 1 has the highest marginal willingness to pay in monetary terms, but level 2 is less, and level 3 is more is less than level 2 and level 1. This is a summary of latent crash model result with autonomous and without autonomous. This is very complicated to explain. So this is an excerpt from latent crash model results. And the crash one represents conservative and conservative consumers. It means negative to next generation models. And the crash 2 is neutral, and the crash 3 is not calculated in this models for this one. But the important thing is gender for conservative and the negative to next generation model includes male and younger and smaller income, and the owner of next generation vehicles are less and the interest in autonomous driving technology are negative, and the preference for autonomous level 4 and 5 is negative. And we'll buy a light car. Light car is a very compact and mini-sized car, unique in the Japanese market. So anyway, so the next slide shows I calculated and estimated multi-profile case with interaction terms. Interaction terms, this is not interaction terms. This is attributes, just attributes, same as this one. Yeah. And okay. This is anyway. So the estimation results of interaction terms, and let me summarize the results and discussion. That and fuel cell vehicle is not statistically significant, but incorporating interaction terms and LCM latent crash model reveals the conditions to be selected: knowledge, income, and next generation model owner, or something like that. And the clean diesel was negative, and the other next generation models were positive. So, and the driving range was significant only for mean parameter, and the reduction of CO2 emission was not significant. But it was statistically significant when the gasoline car was used as a dummy variable. And the interaction terms were useful to reveal the condition: female, higher household income, and respondents who do not own a private car. The autonomous driving was statistically significant at all levels. The coefficient value of level 1 was the largest. Only level 2 shows the differences in consumer preferences. And this is the last slide. And the conclusion. In conclusion, advantage of best worst scaling application to the comparison of vehicles with high awareness of the power source mechanism: gasoline, the hybrid, and green diesel, and the diesel vehicles with lower awareness. So there was a high preference for level 1 implemented in many cars, and level 2 had a variety of preferences, and optional equipment price might be affected. It is necessary to establish legal systems and reduce costs to achieve level 3 and level 4, where accident responsibility switches from drivers to the system. And if consumer awareness changes, it may increase acceptance of autonomous driving technology and drive the spread of autonomous driving technology. Well, thank you very much. And this is the latest.
Thanks to you.
Okay. I'm sorry.
No, it was just to thank you moreover, since It is 2 p.m. Still 2 p.m. in Japan. Okay,
Yeah.
so priority to the audience for the question. I have some, but are there questions in the chat? Not for the moment as far. Okay, if someone wants to ask directly a question, it is possible by opening your microphone. Okay, I don't see any movement. I have a first question. You mentioned the fact that preference regarding CO2 emission, as far as I understand, were not significant from a statistical point of view. But I think you've raised over a question from an environmental point of view, especially as regard local pollution, air quality. Is this something that to what consumer pay attention?
Yeah, okay, let me share the slides. Okay. So I'm sorry, I could not hear exactly. So, but you mentioned about carbon dioxide reduction was not significant.
Yeah, and as far as I remember your conclusion,
yeah.
Okay, so my question is, except for CO2 reduction, have you tried to determine whether the attention of consumer to over pollution, especially air quality, was something important in the choice of mobility means?
Yes. So I skipped then this slide so for a detailed explanation. So, but for some people, so like a female, carbon dioxide reduction is preferable for female respondents and higher income, and car owner for it is not less attractive. So there we can incorporate environmental issues in this radiant cross model results, and but in average the carbon dioxide reduction is not significant, but we can see this parameter was significant. It means there are diversity for consumer preferences about carbon dioxide reduction.
Okay, I have accepted. There was a question from the audience. I have a second one. Do you observe differences between provinces in Japan in your panel?
Preferences in Japan?
Yeah, differences. Meaning that, I don't know, for example, regarding hydrogen, maybe that the network is not
compared with other countries, you mean?
No, from one Japanese province to the other one.
Province, yeah. Yeah, I did not check the detailed estimation, but there are no such different so big differences in compared with other province and the province. So, okay.
Okay, so I propose to thank you again, Kentaro, and to switch directly to Filip Mandys. I see Filip, and we will have a general applause at the end of the session.
Okay. Thank you very much, sir.
And thank you. I propose to switch to Filip Mandys from the University of Surrey. And Filip, you represent a paper entitled Hedonic Pricing of Vehicle Characteristic, Safety and Equipment in the UK car market. And you've got the floor. The rules are the same, 20 minutes.
Thank you, and hello to everyone. I'll just try to share the screen. Can anyone see? Okay. So as Patrice mentioned, my paper focuses on the hedonic pricing of vehicle characteristics, safety, and equipment in the UK car market. So in general, the car market, the global car market currently is entering a unique stage of transformation, where the focus on electric vehicles or environmentally friendly vehicles is greater than ever before. And UK in particular has one of the largest car markets in the world, currently being rated as the 6th largest in terms of sales, with a growing share of alternative fuel vehicles, and therefore it represents a great importance to the UK economy. However, in the current literature, extensive and contemporary insight into what are the main drivers of prices in the UK is lacking. And therefore, the main purpose of my paper is to provide this sort of insight using a contemporary current new data set and applying the hedonic pricing technique along with quantile regressions. As I mentioned, to the best of my knowledge, no study has done this sort of analysis for the UK car market with a recent and extensive data set, while also applying the quantile regressions. So the main aim of the study is to find out what are the main drivers of prices in the UK car market. And as such, the paper answers these 3 main research questions. Firstly, what are the key characteristics, features, or equipment that influence the UK vehicle prices? Then how does this influence differ between conventional vehicles and alternative fuel vehicles? And thirdly, I also aim to construct hedonic price indices, which are adjusted for quality in order to disentangle the growth of prices into quality change as well as other factors. So my research paper constructs and uses a completely new manually collected data set from a wide range of sources, both physical and online. You can see some of the sources of the collected information on the slides, such as, for example, Society of Motor Manufacturers and Traders, as well as Markline's portal, Parker's database, and so on. The full dataset includes a wide range of vehicle characteristics, such as physical characteristics, safety features, equipment, sales, prices, etc. For almost every single car model in the UK car market in the years 2008 to 2019. The full dataset then contains more than 3,000 observations with 67 distinct vehicle characteristics and 144 unique constructed variables. So you can see that the dataset is actually quite extensive. All of the variables were then standardized to mean 0 and standard deviation 1 in order to make the final regression coefficients directly comparable, regardless of which variable we are looking at or comparing. So the main model that I apply to the data is the semi-log hedonic pricing model, which is used to derive prices of the various physical characteristics that make up a composite good, such as a car. And the theory is that the utility in this case is not derived from the composite good itself, but rather from the good's many different characteristics, each which has a distinct implicit price. And the hedonic pricing regressions attempt to estimate these implicit separate prices of characteristics. I used the heteroskedasticity robust reset test in order to identify the optimal functional form of my model. And it identifies it as semi-logarithmic. So you can see the hedonic model equation below, which I used. So I have log of prices as the dependent variable, and then various vehicle characteristics, equipment, features as the independent variables. Before any regression, I also run the adaptive lasso technique in order to reduce multicollinearity and also for variable selection, since the number of variables is very, very large, as I mentioned earlier. The adaptive lasso form can be seen on the screen now, and it works in such a way that those coefficients which are irrelevant for the research are shrunk by adaptive lasso to exactly 0. In that sense, probably the most important parameter in the equation is the tuning parameter, which is lambda n. And the tuning parameter pretty much decides how irrelevant a variable has to be in order for it to be shrunk to 0. So it sort of decides the threshold. I found the tuning parameter using 10 rounds of cross-validation. And compared to the standard lasso, the adaptive lasso is generally superior as it's less sensitive to outliers, as well as to the choice of the tuning parameter. Following the adaptive lasso, I then move on to the regression analysis, running the ordinary least squares, weighted least squares quantile, and also weighted quantile regressions separately for the conventional vehicles and for the alternative fuel vehicles. Furthermore, as I mentioned, I also aim to calculate different hedonic price indices. So in this paper, I calculate the last payer's price index, the hedonic Pasha index, and the hedonic Fisher index. And the hedonic price indices are generally superior in terms of compared to the standard price indices in a number of ways. Firstly, hedonic price indices are able to also consider car models in a vehicle market which went missing during the time period examined, i.e. those models which came into the market after the start of the examination period, or they left the market before the end of the examination period. The hedonic price indices also account for changing quality of the vehicles, meaning that they are quality constant. So they calculate the price index for all of the vehicles, i.e. having a constant quality. And this allows for disentangling the growth of prices into changing quality as well as other factors. So I'll move on to the first set of results, namely the ordinary least squares and the weighted least squares. And my results indicate that the main drivers of the UK car prices in the UK car market are performance, primarily measured by engine power, maximum speed, and acceleration, and also the size or the massiveness of the vehicle measured by vehicle weight and car size. In terms of equipment, I found that the highest effect comes from automatic air conditioning, electric mirrors, and also automatic windshield wipers. The comparison of the regressions between conventional vehicles and alternative fuel vehicles shows that alternative fuel vehicles in general are significantly more sensitive to changes in features compared to conventional vehicle prices, especially in relation to performance, emissions, and extra equipment. So this is the table of the finalized weighted quantile regression. It's a lot of numbers, so I will just note on the most important quantile effects that are found, primarily for the main UK price drivers discovered, which are the performance and vehicle size. The effect of performance is found to be significantly stronger for more expensive cars, or around 10%, around 9% at the 10th percentile, but this increases to 25% at the 90th percentile. So for every each further percentile, the effect of performance grows stronger. Similarly, the effect of size also gets stronger as car prices increase, where we find no evidence of any effect at the 10th percentile and 6% at the 90th percentile. Furthermore, the effect of vehicle equipment also tends to get weaker as car gets more expensive, i.e. they have a weaker effect on the prices for the most expensive vehicles. At the 10th percentile, we found that 9 distinct equipment features are significant, while this decreases significantly over the quantiles. And at the 90th percentile, only 3 distinct equipment features are significant. And finally, for the results of the hedonic price indices, As I mentioned, the hedonic price indices estimate price change for all vehicle models, and it is quality constant, i.e. it shows the evolution of the prices that are unaffected by quality change. And the results suggest that the annual prices, if the quality stayed the same between 2008 and 2019, annual price growth would have been only 1% rather than the almost 3% annually. This suggests that about 65% of the increase in car prices between 2008 and 2019 has actually been caused by improvements in vehicle quality rather than any other factors, which means that due to quality change, prices were increasing about 2% every year. So to conclude, the sort of results that this paper can provide can offer useful information to several different parties. For example, vehicle dealers, manufacturers who aim to optimize their competitive pricing strategies while at the same time increasing their sales. Similarly, confirming the drivers of the alternative fuel vehicle prices can be very important for the UK government, as well as the policymakers, marketers, or manufacturers who look to encourage the adoption of more energy efficient vehicles, which are also more environmentally friendly. This more competitive pricing could lead to higher AFV adoption rates, which is very high on the UK government policy goals, especially in relation to the planned banning of new conventional vehicle sales by 2030 and reaching net zero emissions by 2050. Thank you for your attention. And if anyone has any questions, I'll be happy to answer.
Okay, thank you. The floor is open to Q&A if someone in the recently asked question. If it is not the case, I will start. Could you elaborate a bit, making the link between your observation, the conclusion of your paper, and your recommendation, both to car makers on one side and to policymaker on the other side?
Well, so my results showed that performance and size or the massiveness of the vehicle increase the prices most significantly for the UK car market. And in one of the papers that I'm actually working on right now, I also found that the size significantly affects the current demand in the UK car market negatively in a way, i.e. the consumers would prefer slightly smaller vehicles rather than huge vehicles such as in America, for example. For manufacturers, focusing more on reducing the size of the vehicles while keeping, for example, the number of seats inside intact, could be possibly a good strategy, especially in big UK cities, for example, as in London. You really would want a slightly smaller car in order to get around the traffic, and it could this could help in terms of demand. Yeah.
Okay, but with your method, you mentioned the case of London. Are you able, because you consider a period which is quite long, are you able to take into account the interaction between, on one side, the evolution of the demand by consumer, and on the other side, the evolution of, let's say, collective transport offer and over element of the transport system? And after that, there will be a question of K.
In terms of the public transport affecting either the prices or the demand for vehicles, that sadly wasn't part of the data set in terms of the number of, or the variables that I had at my disposal in the data set. So that would be something that could be possibly added in an extension to the paper or in future research. And your second question, or the second point, you said public transport and one other thing.
Yeah, it was in fact more or less the same question, and you answered that it could be part of future improvement. I see that Rommel has raised his hand. Okay, if you want to ask directly your question.
Yes, please. Good morning together. Thanks for the interesting paper documentation. My question is on fuel tank capacity. Here, is it only on fossil fuels or also the range of batteries?
So the fuel tank capacity is for hybrids and for conventional vehicles. For electric vehicles, there would be I had a separate variable for battery capacity, but because the number of electric vehicles, especially in the early parts of the data set, in the years 2008, 9, 10, there was very few electric vehicles in the UK car market. I think there were just 2 or 3 in the early years, so I had to remove the variable. There just wasn't enough variation.
Okay, I will mention this in my presentation in a couple of minutes. Thank you.
Welcome.
Okay, thank you for this teasing. And if there are no other question, I propose to thank Filip again and to switch to Patrick Bigler, who from the University of Bern. And Patrick, you will present a paper which is entitled Household Preferences for Electric and Hybrid Cars. You've got the floor.
Thank you very much. I'll start my screen sharing. Yeah, thank you, Patrice, for the introduction. Actually, we have changed the title since the submission. So now our paper is now called Welfare, Redistributive and Revenue Effects of Policies Promoting Fuel Efficient and Electric Vehicles. But it's still about the same topic. So we're looking at consumer preferences for, again, fuel efficient and electric vehicles, but we do so with slightly different methods than our previous presenters. So first and foremost, why are we looking at this topic? So as we all know, passenger car emissions are a big contributor to CO2 emissions all over the world, but also here in Europe, or as we are looking at also in Switzerland. So for example, in Switzerland, around 39% of overall CO2 emissions are caused by the road transport sectors, which is a pretty big share. And we have this challenge to achieve net zero by 2050. And we also know that individual traffic is growing and is projected to grow further. So there is a solution necessary. What we're trying to answer in this paper is, so we're looking at what factors drive households' preferences towards electric and hybrid cars. And we also then simulate different policies to show how likely they are to increase the uptake of environmentally friendly cars, and also what kind of welfare implications those policies have. So to be a bit more concrete, we're looking at 3 different policies. So we simulate a price subsidy for electric vehicles. We simulate a further increase in fuel taxes in Switzerland, which is actually very, very important currently, because we have a vote next weekend exactly on like the law that would enable the implementation of this fuel tax. And we also look at the newer policy suggestion, which is this mileage dependent charge, which would take in consideration that if you have an electric vehicle, you're still using the road, but you obviously don't need any fuel, so you don't really contribute to covering the costs of road renovation or road building. Furthermore, we have very detailed data, which allows us to also look at the effect of these policies across the income distribution, which we think is a nice contribution. I'll be very brief here, but the literature has been growing in recent years. So there's various studies that look at the effect of government policies on the adoption of electric and hybrid vehicles. Then there's, as we've seen already today, research in the direction of consumer attitudes and perceptions towards those new technologies. We have so-called peer effects in adoption that have been found. Then an interesting question that has gained more recently is that what does an electric vehicle actually replace? So hypothetically speaking, what kind of car would you have bought if you didn't buy the electric vehicle? And a bit more, as I said, we're also looking at equity aspects and the effect of different policy instruments on vehicle choices. So we adopt this demand model that has been used before in the literature, and we posit this utility equation for household I purchasing vehicle J. So to be very brief, what we have is xj are like vehicle characteristics, very similar to the characteristics we have just heard from Filip. Then we allow certain vehicle characteristics to be interacted with household specific characteristics. So for one example here would be we interact the size of the household with the size of the car, because we think that a bigger household is likely to buy also a bigger car. Then here, this term represents the cost. So we have the logarithm of the price of the car. Then we have those variable costs. So G, I, J are the driving costs. Here we have them as a function of annual mileage, the fuel type of the car, the price of this fuel, and then we allow for a tax on fuel, but also a tax on every mile driven. And then TJ represents the taxes. So there's also an annual vehicle registration tax. We allow prices to heterogeneously, so we allow households to have heterogeneous preferences about the price by dividing the price with income. So we think that higher income households are less price sensitive. Overall, we calculate the net present value of like future expected variable costs. And we do so by assuming a 6% interest rate and a 10 years holding period. This can be done by taking those three assumptions. So we think household take prices and taxes as given. Their future expectation is based on today's value. So we think that based on today's, for example, gasoline prices, households calculate their future costs. And we also think that mileage is inelastic of price. So we suppose that households have a certain limit of mileage they demand each year, and this is to a degree independent of the price of driving. What we do then is, so we formulate this typical logic probability and then estimate our model based on maximum likelihood estimation. So we give each household a choice set, and it consists of in total 489 theoretical options. it's based on one hand on fuel type and on the other hand on the make and model segmentation. So I give here two examples, so a VW Golf or an Audi A6, and then we have whichever combination of fuel type is available. So in the VW Golf, this would be gasoline, diesel, and electric, for example. To address certain endogeneity problems of characteristics and especially of the price, on one hand, we include so-called car type fixed effect. So this would be a dummy variable for SUV, for example. And we also include brand country of origin fixed effect. So that would be like for VW, it would be a dummy for Germany, for example. And we use control function approach to address the price endogeneity. So we use a cost shifter, which is a very specific policy for Switzerland. So we have this fuel economy standard here in Switzerland that, so each importer pays an annual fee depending on whether or not they met this efficiency standard that was calculated for their fleet. And if it wasn't met, they have a quite substantial penalty to pay. We furthermore also include the typical BLP instruments, which are like the sum of characteristics of competing brands, cars, or of like competing models within the same brand's car. As our data, so we have access to several different data sets for households here in the canton of Bern. Since we have a quite international audience, maybe just quickly, the canton of Bern is by population the second largest in Switzerland. It is quite diverse in terms of like rural and urban areas to live. And we think it can be thought of as a pretty good representation of like all of Switzerland also. So we have tax data, so we see income, wealth, and certain household specific characteristics. Then we have all new car registrations in the canton. However, we only observe the ownership in 2019. So we know how old the car is, but we only observe who owned it in 2019, which is why we are only going to use the last 2 years of like car registrations in our data. And then we have several other sources where we take all the vehicle characteristics such as prices and fuel efficiency. And we also add on a geolocated basis, we add the number and location of EV charging stations, since previous research has shown that the presence of charging stations is an important driver of preferences towards electric vehicles. Just very briefly here, we show a few household or generally summary statistics. I did so by grouping them into gasoline and electric vehicles. And as we can see, there's a few interesting things there. So like, for example, electric vehicle buyers have a significantly higher mean income, but also significantly higher mean wealth. In terms of age, they're comparable. They have electric vehicles cost substantially more on average, but are way more efficient. So if we look at the fuel economy, so to drive 100 kilometers, it's almost more than 50% cheaper with an electric vehicle on average than with a gasoline car. So what do we do then? So we estimate, at the moment, we estimate this conditional logit model. We are also estimating mixed logit models, but as you can see, we're talking about 10 million observations. So the estimation is quite expensive and takes quite a while. I will focus here in the presentation not just on column 3, which is the control function approach. So we can see households have, we have a negative price coefficient, so more expensive cars are less likely to be bought. We find very little heterogeneity in terms of price sensitivity by income. We see also households do not like higher variable costs, but the extent is much lower in comparison to the price. So this is a bit like, we have seen that in previous research that households are myopic. Then in terms of car characteristics, we see, okay, households prefer more powerful cars, rather smaller cars in terms of height, heavier cars in terms of weight. Then we have those two dummies for electric engine and diesel engine that are highly significant and negative. We find quite substantial heterogeneity how different sized households value the size of a car. So we see bigger households have stronger preference for bigger cars. We also find some heterogeneity in that older households prefer to buy less powerful vehicles. And then we have all those EV effects. So we interact the electric vehicle dummy with certain household specific characteristics. So in the agglomeration, we have a higher likelihood for an electric vehicle to be purchased. We also see that a dense charging network, so this is the number of charging stations within 5 kilometers, has a positive impact on an electric vehicle being bought. And also we see that there's this growing trend that in 2019, an electric vehicle was much more likely to be bought than in 2018 and in 2017. So based on this estimated coefficients, we then also calculate probabilities. So we see that overall, we have a rather small probability of an electric vehicle to be bought of like 1.6%. It is quite evenly distributed along the income distribution. If we compare that, for example, to gasoline, we see that we have 67% probability of gasoline vehicles to be bought, and it is a bit higher with 68.8% in the first income quartile. So based on this baseline results, we then estimate counterfactual policy simulations. So here we suppose that the law is passed next Sunday and the fossil fuel levy is increased by 0.12 francs per liter. So what we can see is the change in probabilities is that households substitute away from gasoline cars, and they do so again quite evenly throughout the income distribution. What is surprising in our opinion is that even though diesel is also charged a higher price, it is actually more likely to be bought. And we think this has a bit to do with the fact that generally diesel cars are more efficient than gasoline cars. The substitution goes more or less evenly towards all three vehicle classes, and we have like an increasing probability of electric and hybrid vehicles to be bought. If we look at this from a welfare perspective, we estimate the change in consumer surplus, and we see that there's quite substantial change of around almost 7 million in total, but in terms of percentage, it's a rather small reduction of 0.1%. Of course, there's extra income from this CO2 levy. What is interesting is that this extra income is quite evenly distributed again throughout the income quartiles, but of course the incidence is much higher for lower income households than for highest income households. So we see we have this regressive part in the policy. What also happens is, so more fuel efficient vehicles pay slightly lower taxes. So we see that there's also a change in annual car taxes and also a reduction in CO2. If we go further, if we simulate this mileage tax, which we calculated to be around 0.023 Swiss francs, we calculated it by basically assuming that the income from like vehicle policies should be the same as it was in 2010 to sustain like a proper financing of the road infrastructure. Once we introduce this mileage tax, we see that households are now more likely to still buy gasoline cars or to stay with their gasoline cars, whereas everything else becomes less likely. And again, it's quite even distributed over income quartiles. From a welfare perspective, again, we have quite substantial consumer surplus losses. So we of like 0.4% in total. What is positive is, as a government, we have additional income to finance the road infrastructure. But again, there's differences in incidence between the income groups, which is something that might have to be addressed. And we also see the introduction of this mileage tax, since households are then more likely to buy gasoline cars, has a negative impact on emissions, as CO2 emissions are higher in this scenario than they were in the baseline scenario. And as a last policy, we also simulate how an electric vehicle subsidy of 4,000 Swiss francs would affect households' propensity to buy different cars. And we see we have a clear and high increase in the probability that electric vehicles are purchased. It's important here to remember, I know with the 0.004 percentage points is rather small, but we're looking at the baseline level of like 1.6. So the increase of 0.04 from 1.6 to like almost 1.7 is still, it's not a high increase, but it is an increase. And in terms of welfare, obviously the subsidy is appreciated by consumers. So we have a positive consumer surplus change. Again, it's quite even between the income distribution. We also see the subsidy is quite evenly distributed. So it's not that like only high income households would be subsidized. And we also see that in terms of CO2 emission reductions, the reductions are quite substantial and higher than they were in the other two scenarios. So to conclude, we have this overall probabilities to acquire a gasoline hybrid or EV of like 67, 5, and 1.7% respectively. If we increase the fuel tax, we have negative consequences for consumers and comparably small reductions in CO2 emissions. And what we think is important to point out is this regressive effect of the policy. Introducing an EV subsidy, on the other hand, increases consumer surplus. CO2 emission is also decreased, and we think it's quite moderate. Like the costs for the government are quite moderate in terms of like subsidies paid out. And if, on the other hand, again, if this mileage tax would be introduced, people would resort towards gasoline-driven cars, which would lead to an increase in CO2 emissions. And again, the policy is highly regressive, so lower income households are charged more. now I'll be happy to answer any questions or to receive feedback. Thank you.
Okay, thank you, Patrick. Are there questions? Well, I propose to start. As far as I know, Switzerland is a rather small territory at the very center of Europe. And do you have any idea of whether the decision, especially the decision between electric vehicle and hybrid vehicle, depends mainly of the situation in Switzerland, or also depends on decision that will be taken in Germany, in Italy, in France? Because if we compare, this is my perception, the situation in Switzerland compared, for example, to Paris. In fact, in Paris or around Paris, French people will decide to switch to electric vehicle, depending mainly on the French policy. And I don't clearly understand whether it is the case or not in Switzerland, and whether it can have an impact on deciding to choose to directly to switch to electric vehicle, or to prefer selecting hybrid vehicle for obvious reason.
I think it's a bit twofold. So on one hand, I mean, as you said, we're a small country in the center of Europe. We don't have like, no car is produced in Switzerland, so everything comes from abroad, like all cars are imports. So I think in terms of like cars being available and technology being available, we are very dependent on like surrounding countries or the entire world. In terms of what's been decided by the consumers within the country, I would say the policy, like the local policy, certainly has an impact. Like, I don't think it's driven only by that, but I also think like, just because, say, France introduces an electric vehicle subsidy, I don't think it will change much of the behavior of people here in Switzerland. It might like support policymakers to introduce similar policies here, but at the end of the day, I think the consumers react to the policy that we have here.
Yeah, I share your view. If we consider the way French will subsidize buying electric vehicle in France, but in fact the issue is maybe more centered on the financing devoted by France to the development of the recharge of charging network in France, which is in fact quite low and much lower than in Germany, for example.
Yeah.
Okay, but yes, please.
I think it's, I don't know, I feel like I've talked to many people that have an electric vehicle or think about it, and I'm kind of like, I feel like there's this perception in a lot of people that are like, oh yeah, but you know, if like once every 5 years I want to drive to Côte d'Azur for my holidays, I don't know if I can charge it. And this is why I feel like I just buy another vehicle. But I think those are like fears that at the moment are there, but probably will disappear over time.
Okay, I see that there is a question of Kay. Please.
Yes, thank you. Patrick, what is your impression on those policy measures, for example, with free access to bus lanes or to free parking? Do you see any significant effect on those types of non-financial subsidies?
We personally don't look at it, since we know how much people drive, but we don't really see where. So
Okay.
it's hard to simulate it. I mean, I know in the literature we find those results. I just personally, what I think, I mean, they're a good idea in a first step, but they just don't really scale. So
yeah,
I feel
I had more or less the same question than that one. If instead of providing subsidies for buying electric vehicle, if, for example, you clarify the policy in terms of network development in Switzerland, meaning that you will lower the risk, you will provide a much clearer idea of what will be the landscape and the kind of services that can be delivered by your electric vehicle. It could present maybe a more interesting leverage in terms of development. But I understand that it is quite difficult to introduce in your method and to compare it with other tools. Okay, so if all of us agree, I propose to thank Patrick and to switch to Rommel, who will, you belong to the international ISM International School of Management, and you will present a paper which is entitled Consumer Preferences for Innovative Mobility Concept in Germany, and you've got the floor.
Thank you, Patrice. So you can watch my screen. It's available. Thank you. Great. Okay, about consumer preferences for innovative mobility concepts in Germany. That was a project financed by the German ministry until 2017. So the data set is a couple of years old, but you will see we found a very interesting gap with that we can explain the last 3 years in Germany, because you know a lot has happened, but some of those measures were quite problematic. We will see on the next pages. Okay, let me start. In Germany, there was, until that time, a relatively low market share of battery electric vehicles, but of course also high potential. And we saw then between 14 and 17, and also starting at 17 until now, strong growth rates. And sustainable supply of battery electric vehicles here require individual preference structure, knowledge on that, very important. We saw also on the last presentations, and investments in those attributes with currently weak performance. What does it mean? Mainly charging infrastructure is a weak point, and also, let me say, the basis for a gap in Germany between the goals and the real situation. And international research illustrates also at that time, 2017, here that charging infrastructure and range are crucial determinants of market development. And on the other side, determinants for the gap, for problems in development of battery electric vehicles. And we found that between 17, so after we finished our study, and 20, the number of battery electric vehicles in Germany has increased by the factor 13, so very strong. But the number of charging points at that time has increased by the factor 6, so less than the half of growth rate. And this is also a problematic situation. So high preferences for these attributes in combination with insufficient infrastructure require further clarification. On one hand, the development in Germany is quite well. Also, the charging infrastructure has increased, but you see there are now new problems arising. And in particular, range, charging infrastructure, and price hinder still the majority of consumers to use electromobility. So we concentrate on a better performance of these attributes. We used a discrete choice experiment to estimate marginal willingness to pay for changes of the crucial attributes of mobility products. And the results of our survey identify the drivers and obstacles for the uptake of electromobility in Germany, and to explain the still existing gap between the number of vehicles on one hand and the problems in charging infrastructure. Okay, so the goal here is to use information on consumer preferences for single attributes of mobility. And the main question is, can additional willingness to pay for those types of vehicles be sufficient to cover the higher costs for those technological solutions? And second, what are the implications for policy support? So what we discussed in the last presentation, what are the difference, for example, between financial support and non-financial support? And what might be contradictory effects of financial policy support? So we had an online survey with 405 completed questionnaires from respondents in Germany. So we had a focus on North Rhine-Westphalia and Bavaria. So it's not fully representative for Germany, but for those huge countries, Bundesländer. And the emphasis of this willingness to pay for single attributes of products on markets for electromobility. We see here electromobility, but we had also the focus on car sharing. All of those 405 respondents were presented with us 12 choice cards. So that means we had 4,860 choices. What does it mean in details? We tried to construct a hypothetical market situation with this discrete choice experiment, so DCE. And our purpose was here to provide some estimations, some evaluations on public support and marketing for battery electric vehicles and other alternative vehicles. So the theoretical model of this choice, and that was mentioned several times earlier, here is the total utility based on this function, including the elements of these attributes we decided to use. So price, running costs, park and ride or free park or bus lane access, so beta 4, 5, 6, and beta 7 and 8 range and availability. So the utility of electric vehicles, or EV, represents the utility the respondent received from this specific configuration of the battery electric vehicles. So the beta BEV represents a change in utility. And for each vehicle type, you will see on the next page, presented in that choice set, the respondent chooses a vehicle type that provides the highest level of utility. And we had, what I said, 12 choice cards, so 12 different choices for each respondent. So the choice design was the selection of attributes and levels based on expert interviews. So we used the Delphi method to identify the important attributes and levels with a number of experts on markets for electric vehicles. And we decided here to use choice cards, including 6 attributes for 5 different vehicle types, plus the option car sharing. So of course, car sharing is an outstanding situation because it's not a purchasing process of the car, but it's a purchasing process of the mobility service. And we had a range between conventional vehicles, or the standard, different types of hybrid vehicles, electric vehicles, or HEV or plug-in, and range extender, and also the traditional classical form of battery electric vehicles. Here you see not the choice card. The choice card will follow, but this is the entire range of attributes and levels. So of course, in the choice card used by the respondent, we have these different attributes. So these 6 attributes representing the standard design of a product. So price, power, running costs, different types of boni, range, and availability of charging stations. We had the standard for conventional vehicles here in the first column you see, then hybrid electric vehicles, battery electric vehicles, range extender, plug-in, hybrid electric vehicles, and car sharing. What you see in the boxes here, for example, for hybrid, you see the price in percentage of the reference level for conventional cars between 80% and 140%. And one of these levels then is a part of the choice card, of a single choice card. And this holds for all of those boxes. So the respondent then is confronted with a specific situation with one of these 4 or 3 levels. And some of them are dichotomous, or you see here we have this numeric variables. And then in the next step, the respondent will presented with this choice set. Here you see one example. So each of the respondents received 12 different options. And then the respondent was asked to choose here to select one option, or no option is also an opt-out option for the respondent. And this is, of course, only an example. HEV could be with 80 or 140%, and that is the case maybe in the next choice set, or choice set number 2 for the respondent. And then you have for each type of vehicle a certain situation, a certain design of the product, for example here, hybrid or battery electric vehicle, and the respondent then can decide to choose that option or not, or to choose another option or no option. And then here for the results, we expand this model, this disparate choice experiment, with a so-called latent class model. That means the software builds 2 different classes. More is possible, but we decided to select or to develop only 2 classes, class 1, class 2. And here you see the class probabilities. So the class membership is partly influenced by social demographic variables like gender, age, for example, or the living situation, tenant or landlord, income is also important. So you see, gender and income do not have a statistically significant impact, but age here in the second line, and rent also in the third line. So if the person is a tenant or not, this has a significant influence on the class membership. That is the first step before identifying the determinants and the willingness to pay. Yeah, younger respondents and those who have rented an apartment are more likely to be member of class 1. And on the next pages, we will identify what are the main differences between class 1 and class 2, because we identified here class heterogeneity. So preference heterogeneity is present due to differences in covariates between the classes. And on the next page, you see the results for the different classes. Not for the single attributes that will follow on the next page, but here for the different types of vehicles. These different types, so 5 different alternative types and the conventional vehicle, CV. And what is very significant, so the first class, or the members of the first class, which is a little bigger than the second class, has a slightly higher share. And the main distinguishing factor between the 2 classes is the acceptance of battery electric vehicles. Here you see a huge difference. So the significant value in class 1 is very high. in relation to class 2. The conventional vehicles are more preferred of members in class 2. There's also a huge difference corresponding to the first finding. Range extender is also highly preferenced here in class 1. Plug-in also, difference is smaller, but there is a significant difference. And car sharing is more preferenced by members of class 2. So we found class heterogeneity and strong preferences for battery electric vehicles only in class 1. What does it mean? Here you see the willingness to pay in percent for significant attributes in comparison between the two classes. So first, of course, not a surprise, for a decrease in usage costs by 1 euro cent here, people are willing to pay between 10 and 8% more for purchasing. And we checked these results with real prices on German markets, and we found that that's a quite good picture of the real situation in 2020. What else can we see? You see here the bony park and ride or usage of bus lanes is negatively correlated. It means there is no preference for these systems, and those who selected conventional vehicles as a first option, that is the reason for the negative relation. But the final result is those non-financial support, those policy measures are without an effect, a positive effect on the willingness to pay for battery and other alternative electric vehicles. And another point is, you see an increase in range by 100 kilometers. People in class 1 are willing to pay 9% more. And the high availability of petrol stations, that's a main finding here, will lead to 27.4% willingness to pay. Now, there were strong effects of changes in the charging infrastructure. That is the main outcome here of our results. And you see also, in addition to that, between the classes, so class 1 and class 2, there is what I said here, a strong preference for lower prices. That is not a surprise, but we can confirm other findings of other studies. And for example, power is with no significant effect, but usage costs, as I said. The bony system is for some significant, but with no positive effects, what I said, but range and availability of petrol stations is for class 1 highly significant. Okay, sorry, I forgot to show you this text, but that's the same what I said in my own words. And this is exactly what you see here with these findings. So non-financial support has no effects, and lower prices are still the most convincing argument to buy battery electric vehicles, but we see strong effects on social demographics because of the heterogeneity between class 1 and class 2. And that means for these social demographic effects, the findings that younger people and tenants are more likely to opt for alternative vehicles. And that means for German policy, I will go on the next page, for the German policy, so the availability of charging stations is a problem because, what I said, the growth rate of charging infrastructure is much lower, much slower than the growth rate of the number of vehicles, battery electric and hybrid plug-in vehicles. So here there is a great need to communicate various advantages of improvements in grid infrastructure. And this is the main problem in German policy. There was done a lot, but not enough. And we need here intelligent business models to increase the market shares for battery electric vehicles. What we can see in big cities like Berlin, Frankfurt, and some others, but in lower cities and in the rural areas, we have still this problem that the grid infrastructure, the charging infrastructure is much too small and slow growing. And another problem, there was a huge financial, or there is still a huge financial support granted by the German government, so several thousand euros for purchasing a battery electric vehicle. And this has shifted the demand curve for battery electric and plug-in electric vehicles, so upwards. But here, the growing market size at the same time has increased the gap between the high priority of available charging points and range on one hand, and the number of those types of vehicles on the other. And this is still the main problem for German policy. So more concentration on young tenants in urban and suburban areas is very important. And also in Germany, the negative effects of increasing the battery charging station is also underrepresented. And this might be another obstacle for an increase in charging infrastructure, because a growing number of young people, you know this, Friday for Future, are also very skeptical for electromobility because of the battery problem. Yeah, and here you see low impacts of public incentives. So public measures such as boni are limited, and many municipalities in Germany have identified this problem and the very low effect of those measures. Okay, thank you. That's all for the moment. Now the floor is open. Thanks a lot.
Thank you. I confirm that the floor is open. Maybe I can start. Do you think that on one side, at the center of the market, there are people that try to determine whether they will buy, let's say, some kind of electric vehicle, but on the other side, you have maybe consumer that say, well, for the moment, if I want to have a car that is more clean, maybe that biogas is for the moment a better option, and that there are maybe other consumers that say, well, maybe that the electric vehicle is not the solution, and waiting for hydrogen is something that could make more sense. Do you find that kind of debate in Germany?
Yeah, we have that debate. So with gasoline, so gas engines are quite cheap. The running costs are quite cheap, but many people do not invest in those types of cars because of high investment costs and nearly no public support, financial support. But I think so many people, a growing number of people have problems with negative environmental effects of battery electric vehicles, and this might hinder those people for purchasing those cars. But again, the big problem is what also was mentioned by Patrick. If a person have in mind not to visit the Côte d'Azur, because we don't have the Côte d'Azur in Germany, but maybe to living in the northern part and visiting the Alps in 3 years, and they have fears that the battery range and the charging infrastructure is too weak, and this is the main obstacle in Germany. But again, the number of vehicles is not the problem, but the charging infrastructure is the main problem, and there are more investments strictly needed.
And regarding hydrogen, which is more and more a keyword that we find in any public, in many public announcements in Europe, is this something that appears to be new for consumer in Germany, and that may modify the choice for the future?
You mean the existence of battery electric vehicles is new?
No. The fuel cell vehicle and the fact that more widely in the Green Deal in Europe, and as far as I know, this is the case in the German policy, in the French policy, in the Italian policy, we find hydrogen anywhere, and maybe this is something that could have an impact on consumer choice.
Yes, I think so. My impression is in that direction, but unfortunately, at 2016-17, when we developed our research design, we haven't focused on that. So this is a very important new or current objective for next research on that. I think this is a new upcoming problem because it's an obstacle. It might be a purchase obstacle.
Okay, we have two questions. Patrick, first of all, and Eva after that.
Yeah, just a small question. I was wondering how you define like charging points generally. So is that like only public available, or do you also observe like if someone has like a charging point on their own in their own garage, for example?
Yeah, we concentrated here on public charging points. Okay. Of course, in addition, we have those charging stations in firms, companies, and at home. Of course, if the number of those charging stations will grow, but it's limited in Germany, the share of rented flats is quite high, higher than in many other countries, even in the former Western part. Therefore, so many tenants, they don't have options for own charging stations. So, but you are right, we could expand this on private charging stations, and then the situation would be a little better, but the basic problem is still remaining.
Yeah, I think it would just be interesting to see if, for example, the private charging points have grown stronger than the public ones, like a comparison of that. Because I think, like again, coming back to our data, what we see is that, as you say, we don't really observe the vehicles from people that live in like multi-family homes in the city centers, but more from people outside where there's like, I would suspect private charging options are easier to implement.
Yes, I agree. In 16-17, when we constructed the study, that was not such a big development as we have now. But of course, yes, a new research on the current situation in Germany with more private charging stations would present maybe a different picture, but I'm quite sure the basic problem is still remaining. But of course, this would be one option at that cities or places where it's possible.
Okay, we still have time for a very last question. I see that Eva has raised. Yes, please.
Yeah, yes. Hi, thanks a lot for a very interesting presentation. I have three small, more technical questions. Just so I was just wondering, but they are very small. So I was wondering, how was the survey conducted? How did you collect the sample of these 405 consumers? And I was wondering whether you could share what software have you used for this? And as well, I was wondering what in the survey, so did you check what car consumers already have? Because as I understand that you were targeting the future decision of purchasing a car, right? So did you control what they already have, like that they already have a certain type of a car? Thank you.
Yes, thank you, Eva. So we conducted an online survey in 2016-17, and we used Stata software to run the discrete choice experiment. And we asked the respondent for their if they have a car and what type of car. But I haven't inserted this here in the GCE results. But yes, I have it. I don't have it available here, the result, but we considered this. Yes.
Okay, maybe a very last question. Compared to France, the policy in Germany, as far as I understand, is much more locally designed. And from that point of view, do you have are there more successful lender, more proactive lender?
You mean on the federal level or on the local level?
Yeah. As far in France, most part of the policy is centrally determined, and this is not the case in Germany. And do we observe very different policies from one land to the other in Germany, and with more successful experience?
Yeah, in Germany, we have also those centralized decisions on financial support. So only the federal government can decide on this financial support for electric vehicles. But on the municipality, on the local level, they can decide on those boni systems. But what we found, and also in other studies, there is less or no effect of those local instruments. Therefore, at the end, we have more decentralized types of measures like financial support. And the lender, though the countries have also some space, but less. But you see, maybe yesterday there was an election in Sachsen-Anhalt in the eastern part of Germany, and the Green Party has 6%. So in those countries, the awareness of those problems is still quite low.
Okay, thank you. I don't see any other question, and we are short of time. So I propose to close the session, and we can upload our participant.
Thank you.
Thank you.
And maybe with a special thank to Kentaro, who spoke from Japan. Okay, I hope you will be able to attend over a session of our conference. Some of them will address also electric vehicle issue or vehicle to grid especially. So I hope to see you in that session or over once. Bye-bye. Okay, Diego, thank you for the technical assistance.
Thank you. Goodbye.
Thank you.
Merci. Bye-bye.
Have a good day.